So what Elasticsearch is, it's a very buzzwords compliant piece of software. It's open source, it can do REST, JSON, HTTP, it has real time, there's Lucene somewhere in there. It's very buzzword compliant. What it actually means is a distributed data store that's very good at searching and analyzing data. That's what you should take away from this slide. The rest is just gravy. So how do you start with Elasticsearch? First, you need to install Zookeeper and no. So you download it, you untar it, you run it, you're done. So it's really that easy. I just have to inform you, if you try it right now, all of your notebooks will probably form a cluster, which you probably don't want. So just a little bit of advice. If you do want that, that's perfectly fine. It's a very good way how to steal data from people at a conference. Because when two computers join, they'll share data. So the first step, what you do with the data store is you shove some data in. In this example, I'll be using curls for all the examples. There is obviously a Python client, which I'm working on, but curl is the lingua franca of HTTP, so we'll use that. So you just put in an index with a type and an ID, and you put some JSON document in there. You can immediately get it. You can delete it, you can update it. You can update it by posting a partial document that those two then will be merged. You can update it using a script. You can even do upserts. Nothing groundbreaking there. So you have data. What do you do with the data? So first thing you do with the product that's called Elasticsearch is that you actually search. So there is a convenient shortcut. If you just do _search, Q equals meetup, it will just do a search for meetup. It will search across all of your indices, all of your types, all of your documents, all of them fields. So this is, if you really want to make sure that it's working, just do this, which basically translates into something like this. I just added one more thing, and this is for people that are familiar with search. This is passed into Lucene as a Lucene query syntax. So it's very powerful. You can do all sorts of stuff, but it's sometimes hard to read. And besides, you really don't want to be in business of concatenating strings to do a search request or anything like that. We've all been there. Let's not do it again. So how you actually query the data is we have some query DSL built on top of your favorite data format, JSON. And this is what a typical query would look like. It's a filtered query that has a query part and a filter part. We'll talk more about the difference later. And the query is a bool query that has a must part. So it's saying that in title or body there must be Python, and it's saying must not. So in title there must not be PHP. And then we are just filtering events from this year. So the difference between filter and query: filters are fast, cacheable, and don't contribute to the score. It just limits your result set. It doesn't do anything with the score. Whereas query will actually determine how well the document matches. So this is just does it match or not, and this is how well does it match. So here I'm indicating that title is more important to me by a factor of 10, whatever that means, than body. So I'm telling Elasticsearch, I'm telling my search engine that title is more important. Note that it will do something similar like that because title is generally a shorter field, but I can make really sure that it does it. So because filters are more performant and primarily are cacheable, always use filters. Only when you cannot use filters, use queries. Just thumb rule. Ah, okay, and it looks better. So we've seen a query. Now query will only give you back the documents. By default, it will give you the top 10 best matching documents for your query. You can also append something that we call facets, which are basically aggregations. Here are two examples. If we are searching over an imaginary index that contains meetups, we can have an aggregation that we call monthly meetups, and it will, based on the date contained in the field event date, it will do by month, it will do counts. So this will give me only for the documents that match. So for meetups that have Python in title or body and doesn't have PHP and have been in the last year, it will give you per month how many meetups were in that way. And the second one is more interesting. So for each topic of those meetups, which mostly it's going to be Python, but we will see some statistics on the number of attendees. By some statistics, I mean the usual suspects. Sum, count, average, standard deviation, very basic statistics. So for each topic, for example, Python, big data, and everything, we'll get how many people generally attend and what are the statistical characteristics. And this we can do on any search. So already we see how it can be useful because we can do aggregations against any field, not just something that we are searching on, but any field on the index. That's one brilliant part of Lucene. It creates an index on every single field you put in it by default. So now let's go a little crazy. So you're not supposed to be able to read this. It's okay. And this is just a simple query that does all that stuff. So it still has the Boolean filter. In this case, this is an actual query that runs against the data set from Stack Overflow, and it will actually filter questions based on the answers. So there is some form of relationship going on in Elasticsearch that you can define. You can say that these two types, in our case questions and answers, have a parent-child relationship. So what we are saying is that answers belong to a question. So then when we are searching on a question, here you can obviously read that we are searching questions. You can see, give me only the questions that have answers that match this query, which is what's happening here, obviously. And then we do another cool trick. We actually take the rating that's part of the Stack Overflow data, which is user contributed. It's generally more reliable that something will come up with an algorithm on how good the question or answer is, and we will take it into account when combining the score. We will not sort by it. So something that's a very good match, but not really a good question, it has very low rating, will still show up at the top. And something that's not that good a match, but it's really good question, will also show up there. So generally something that users would want from your search. Then it does some faceting and some HTML highlights, not very interesting. So how does this actually look? Now is coming the interesting part. We've had so much great success with technology. So this here is Kibana. It's a front end for Elasticsearch. It's a purely JavaScript application. I know I'm at a Python meetup, but this is more impressive. And what this basically does, it queries data in Elasticsearch. It was already written as a complement to Logstash, which takes all the logs from your servers and stuffs it into Elasticsearch. And this was written for analyzing that data. And we can do some pretty interesting things. I have some very simple dashboard prepared for you. So this is a histogram of all the questions from DBA Stack Exchange. This is a breakdown by tags, and this is basically just a number of these 3 queries, which you can also see broken down here. So I decided to break it down by the number of comments that a post has: 0 to 2, 2 to 4, 4 and more. And here you can see that it's actually pretty fast. This is querying the entire data set from DBA Stack Exchange just on my notebook. I can do filters. I can click on the tag, hopefully. No, have I been lying to you? No, I haven't. And everything immediately changes. I can change these queries using the full power of a search engine. So let's see if DBA's actually searched something in Python. Yes. And here we have the actual results, the actual data. We can just click on the document, inspect all the fields. So this is something that you can do with Kibana, and I'm showing Kibana specifically because it's written in JavaScript, so you can be absolutely sure that none of these aggregations, none of these things are happening in the browser. It's all happening with Elasticsearch. You can actually, for each of the panel, you can just click here and see the query that is actually running to get the data exactly in the format. So this is something that Elasticsearch can do for you. There are people that do these sort of things on a data sets that have multiple tens of terabytes very, very easily because of the distributed nature of Elasticsearch. So running out of time, so let's find my slides again. What happened to my slides? So the demo god has listened to our prayers. And let's just do a quick run through of some of the other cool features. One of my favorite features is a percolator. What percolator is a reversed search. So instead of indexing documents and then running queries, you index queries and then you run documents. How it works is, for example, imagine that you have a site like Stack Overflow and you want to create alerts. So I, as a user, come to your site, I define a search, and I want you to give me alerts when any new document comes in that matches my query. This is it. I just put in the query, and I can use all the power of Elasticsearch in this query. And then when I just send in a document, it will give me a list of queries that actually matched. So if you have a feature like that, you're done. Like this is all you need to do. In here, you can limit the queries that should be tried. You don't have to always run everything. You can actually do a query on the queries and only have those queries that match that query, matching the queries, run against the document. But because it's very difficult to explain in 20 seconds, this is a very simple example. So that's one cool feature. Then we have two suggesters. Suggesters are something different from search. We have one for autocomplete and one for spell checking, pretty much. And the thing to note here is suggesters are fast. And I mean, we try to be very fast on our searches as well, but suggesters, if we don't do a 10,000 queries per second on a single machine, we are doing it wrong, and we really hope we are not. So autocomplete, you can define a suggester, then you just do partial note that you can add some payload to all the things that you want to potentially autocomplete. We're running out of time, so did you mean? Some people don't know that the whiskey is actually spelled differently, Johnny, so we have a phrase suggester that's context aware and that can give you spelling suggestions based on actually the context from your own data. And the last part is just very simple. Yes, it is web scale. We have customers that have over hundreds of terabytes of data in a single cluster. It still works. And that's it. This is how it looks. If you have one index, it's by default divided into 5 shards. So this is a situation when I have one index, 5 shards, 3 nodes. This is how it's distributed. If I were to kill one node, it would just associate the new replicas and heal itself. And that's it. So what wouldn't you use Elasticsearch for? It seems to be great, but seriously, what doesn't it do well? So there are several limitations. One of the limitations is if you put something in, it will not be immediately available for search. You can request it that it will be immediately available, but it's a potentially expensive operation. By expensive, I mean tens of milliseconds or something like that. Nothing brutal, but by default, it will only be available after a second. So that's one thing. If you know that that's only for search. If you want to get it by ID, it will always work like this. I wouldn't use it anywhere where you need transaction across multiple documents. When you where you need stuff like that, and I cannot think of any other examples. It's generally pretty good with the combination of structured and unstructured search. If I think of anything else, I'll let you know. What's the replication speed of data across the cluster? And does Elasticsearch natively support plugins? Plugins handlers which can handle insert, update, delete events. Okay, we have support for plugins. If you write any plugin in Java, you can do absolutely anything. But remember, with great power comes great responsibility. If you don't do something right in your plugin, your cluster will fall, because you can actually dabble with the very internals of Elasticsearch, of Lucene from the plugin. So you can do absolutely anything in a plugin. Also remember, it's all HTTP. So if you just want to log something, if you want to do some very basic ACL, you can just put a load balancer in front of it, do a simple filter on the URL patterns or on the methods, because it's REST. So if you only allow get method, you will only be able to search. So that's a half-ass response to that. I'm not sure whether there are some already made plugins that would hook up into that cycle. Were you joking about the auto cluster forming? Okay, what are the security implications of running Elasticsearch? No, I wasn't joking, that's the default. We tried the default to be as developer friendly as possible. Know that this is not a setting that you would typically run in production. First, there are several ways how to limit the cluster formation. The simplest one is if you just name your cluster, it will only form cluster with the Elasticsearch instances that have the same name. So that's the first step. That will work even now. If you just name your cluster, which is just one file, one line in the YAML configuration file or JSON configuration file, you can choose. That should be enough. Also, you can disable the automatic multicast discovery. You can just use a unicast and a list of seed nodes. So when the new node comes up, it has a seed nodes that it will try to talk to and get the members of the cluster. You can do it completely manually. So I was not joking, but the security implications is don't run the development settings in production. Really don't. And also for those of you who have, for example, VPN access to production, if you don't change the name, cluster name on production, you have the multicast enabled, and you connect to the VPN in production with your node running on your notebook and your site is going to die. This has been known to happen. Like suddenly, because the cluster, hey, there's a new machine, let's offload part of the load there. Suddenly, you're serving production data off your notebook and you generally don't have enough space or processing power. So, something to be aware of. It's definitely solvable, it's not hard, but there are many a developer who did it wrong. Okay, so that seems to be all of the questions. If you have any more, come talk to me. I'll be more than happy to. And thank you for having me.